In stoichiometry, we want to be able to convert from grams of one reactant to grams of either another reactant or a product. And we want to be able to go in a stepwise fashion. That's shown here in this slide. So if I have the generic equation A to B, I'm going to go from grams of A to moles of A using the molar mass of A. Convert from moles of A to moles of B using the coefficients from my equation, and then convert from moles of B to grams of B using the molar mass of B. Now this seems like it's a daunting task right now, but all we have to do is break our equation up into small stepwise pieces and everything will come into play. So let's go ahead and give this a try. How many grams of NH3 are made when 2.55 grams of N2 are used with excess H2 in the Haber reaction? So you recall from the previous video, we showed that the Haber reaction is N2 plus 3H2 goes to 2NH3. So our overall process that we want to set up here is we want to go from grams of N2 to moles of N2. Then we're going to go from moles of N2 to moles of NH3. And finally, from moles of NH3 to grams of NH3. So the first thing we want to do is start by writing down our starting mass of N2, the 2.55 grams. Then to convert from grams to moles of N2, we need to use the molar mass. Nitrogen by itself is 14.01 grams per mole, but because there's 2 in N2, we have a mass of 28.02 grams per mole. Well, we got to put the grams on the bottom and moles on top. So we have our conversion factor of 1 mole of N2 divided by 28.02 grams of N2. Next is to convert from moles of N2 to moles of NH3. From our equation, we're going to put 1 mole of N2 on the bottom and 2 moles of NH3 on top. And that's going to allow us to convert from moles of N2 to moles of NH3. Finally, the last bit of the puzzle is to convert from moles of NH3 to grams of NH3. And we do that by using the molar mass of NH3, which is 17.03 grams. So 17.03 grams of NH3 on the top and 1 mole of ammonia on the bottom. And we go through, type all this into our calculator, and we're going to get 3.10 grams of NH3. As we go through, we'll see that the units, the grams of N2 cancel out, the moles of N2 cancel out, the moles of NH3 cancel out, so that we only end up with grams of NH3 at the end. If for any reason that you don't get your units to convert out, you might have your conversion factor upside down somewhere. So make sure that you have all your conversion factors set up so that your given unit cancels out with your given unit, and then your desired unit cancels out with your given unit in the next conversion factor. So let's go ahead and try another one of these conversion factors. In the combustion of thermite, how much iron is produced if excess aluminum is reacted with 15.0 grams of iron 3 oxide? Well, the first thing we have to know is what is the equation for the thermite reaction. And that's going to be Fe2O3 plus 2 aluminums gives 2 irons plus aluminum 3 oxide, or Al2O3. So now that we know the equation, we're going to set up our desired conversion that is asked in the question. We're going to start with the 15.0 grams of iron 3 oxide, which is rust. And we're going to convert that to moles of Fe2O3. And then to get to our desired mass of Fe, we have to convert from moles of Fe2O3 to moles of Fe. And then finally from moles of Fe to grams of Fe. So we're going to do that, and let's start with the 15.0 grams of Fe2O3. The molar mass of Fe2O3, which is our first conversion factor, is 159.7 grams, and we're going to put 1 mole of Fe2O3 on top. Now that our unit is in moles, because our grams of Fe2O3 cancel out, we're going to convert from moles of Fe2O3 to moles of Fe. And from our equation, it's going to take 1 mole of Fe2O3 on the bottom and 2 moles of iron on top in order to convert to our moles of iron. Finally, the last step is using the molar mass of iron to convert from moles of iron to grams of iron. The molar mass of iron is 55.85 grams from the periodic table. And when we plug everything into our calculator, we're going to end up getting 10.5 grams of iron made. So we take 15 grams of Fe2O3 and we make 10.5 grams of iron. I know this video is getting a little long and we've done this 1 or 2 times already, but let's try one more example. How much water is made during the combustion of 25.3 grams of C2H6O with excess oxygen? Okay, so the first thing we're going to do is find our equation for the combustion of C2H6O, and that's going to be C2H6O plus 3O2 goes to 2CO2 plus 3H2O. So for every mole of C2H6O I have, I'm going to produce 3 moles of H2O. So let's get our overall game plan. We're going to convert from grams of C2H6O to moles of C2H6O using the molar mass of C2H6O. Then I'm going to convert from moles of C2H6O to moles of H2O using the coefficients in my equation. And then finally, I'm going to use the molar mass of H2O to convert from moles of H2O to grams of H2O. So let's start this off with the grams of C2H6O, which is 25.3. I'm going to multiply by the molar mass of C2H6O, which is 46.07 grams on the bottom and 1 mole on the top. Then my molar conversion is going to be 3 moles of H2O on top and 1 mole of C2H6O on the bottom. Finally, 18.02 grams of H2O goes on top, 1 mole of H2O goes on the bottom. When I look back, all my units are going to cancel out. The grams of C2H6O cancel out, the moles of C2H6O cancel out, and the moles of H2O cancel out to give me grams of H2O. Plug everything into your calculator and you're going to get 29.7 grams of H2O out. So now that we have seen 3 conversions of using stoichiometry, I hope that the name doesn't bring any fear to you and you just see this as just putting our conversion factors together and using the coefficients in our equation to do molar conversions of one molecule in our equation to another. So make sure that you guys look through this, look through the next couple of videos that are going to go and use this in a little bit more detail, and be prepared to work on stoichiometry in class.